Okay, so let's move to one-dimensional motion in the vertical direction, where the acceleration is due to gravity. And in that case, if the downward direction is negative, we'll have minus g, where g is some positive number depending on the units. So for example, in meters and seconds, g is 9.8 meters per second squared. So we integrate to get v. Of course, the acceleration is independent of time, and of course space as well, as an approximation. So the equation is reduced to v naught plus at becomes v naught minus gt. That's the speed kinematic equation. And then we have the position kinematic equation, which now we write as y. Y equals y naught plus v naught t. It's really the v naught in the y direction. It's really initial speed in the y direction. So that's a vertical component in this case. Plus the 1/2 at squared becomes minus 1/2 gt squared. So those are the kinematic equations for the vertical direction if gravity is acting in that direction. So let's do a problem where we launch an object from the ground. Here is the object, and we launch it from ground at a speed, let's say, same as the previous example, but upwards now, so v star, and we want to know how far up does it go. So what is the y max? Right, that's the question. So we look at the y equation, and that says y equals the initial y. So if we call the initial y at ground level y naught equals 0, then that's 0. What's the initial speed? Well, it's v star. So that equation becomes, the first kinematic equation becomes v star times t minus 1/2 gt squared. And like we saw before, we don't have the time. So this is very similar to the previous problem in the horizontal direction. And now we go to the second kinematic equation to get that speed. And what does it look like? Well, it becomes v star minus gt. And we notice that instead of writing v here, we want a very specific v, which is the v when the object reaches its maximum height, and that must be 0. So we need to think of the dynamics to be able to figure out all of the quantities in these kinematic equations. And so that set of equations now gets solved in the same way that we solved it before, but in this case we get a time which is v star over g, and we're going to plug that into y to get v star times v star over g minus 1/2 g times v star over g squared, and that will give us a v star squared over 2g. And so that's the height, that's the maximum height reached by this object.